So now that we've covered solutions to linear equations that have two variables, we want to take some of that at least and extend it to inequalities in two variables. So when we talk about inequalities in two variables, now we're not talking about just a line, we're actually talking about part of that plane, part of that grid that is also going to meet the requirements of that inequality, points that when you plug them into that inequality are going to have the less than or the greater than or whatever the case may be. And so what we have is not just the line that's important, but also when that line cuts our grid into two pieces, which of those two pieces will also be part of our solution or solutions to that inequality. So the first part of what we have in our procedure here deals just with the line part. So if we replace the inequality symbol with an equal sign, we've got a line that we are accustomed to graphing. But we have this extra dimension because the problem started out as an inequality. We've got the possibilities that the inequality symbols have that or equal to, which we're kind of saying, hey, let's put the equal to in there. Well, if it was already there, we can go ahead and graph things like we normally would, where we've just got a solidly drawn line. But if that equal to part wasn't there originally, if we had just a strict inequality symbol, less than, or the greater than, then that means that those points on that line are not going to be included in the solutions to that inequality problem. So, dashed line to represent that those points are not going to be included. That takes care of the line part. So again, the line's going to cut our grid, our plane, into two different pieces, no matter whether that's a vertical line, a horizontal line, or some sort of slanted line one way or another. We've got two parts of our plane, two parts of our grid. And so we need to pick some sort of point that's not going to be on the drawing that we created and test that in our original inequality. Either we're going to get a true statement, in which case wherever that point came from would be colored in because that point's going to represent all of the other points from that section, and those do in fact work. Or if we've picked a point that ends up giving us a false inequality statement, then we would end up shading the opposite region of where we had picked our test point from. So we've got one example already worked out, and another one that we'll do together. So as far as, again, the first part of this, where we want to figure out what line we have and how it's going to be represented, we're going to replace the inequality symbol with an equal sign. We can make a note, either a mental or written note, that when we do graph that particular equation, we're going to use a solid line because the original inequality symbol did have the or equal to part already appearing. So a solid line for graphing that. Now if we go ahead and use that idea that we had mentioned previously about taking our equation, solving it, putting it into the slope-intercept form, using the slope and the y-intercept in order to be able to draw our graph, then we would get our y-intercept. From there, we could use our slope to move to the right 3 and up 4, or move to the left 3 and down 4, and have enough points to be able to draw in our solid line. Then in the second step, we would want to pick a point that is not already on that pink line and test it in our original inequality. So if we could have picked the origin, that would have been great, but the origin's part of the line that we've got. So picking something else that's on the x-axis or the y-axis is pretty convenient for us because that means at least one of the values that we're plugging in is a 0, makes things a little bit quicker to deal with. So always a good idea to be smart, work smarter, not harder. So what I've done here is pick the point 0, 2, and you can see that green point represented here. I'm picking that particular point, I'm putting it into that inequality and testing to see if I get a true statement or a false statement. So what comes out of this is in fact a true statement that negative 8 is less than or equal to 0. Since that's a true statement, I'm going to shade the part of my drawing that contains that point, which means that you could say either the left of our pink line or above our pink line, one way or the other. I want to shade that region that contains that green point that I've picked. So that means that what we've got in this picture is that everything on the pink line and everything that has been shaded in is going to be considered a solution. So all of those different points that are colored, shaded in our turquoise blue, all the points that are on our pink line, all of those points could be plugged into our inequality symbol and they would all yield true statements. So the nicest way of trying to represent that, other than the inequality itself, the nicest way of representing that, visual form. So let's do one of these together, work through things slowly so that you can get a better feel for what's going on here. And not surprisingly, we've got things already mapped out a little bit here for how we want to work things. Step one, like before, we're going to want to say what equation it is that we want to graph. So we're going to take the inequality problem, which starts with 2x plus 3y. And instead of the greater than symbol, we're going to put in the equal to symbol so that we have a normal equation, so equal to 6. Because we just noticed that we have a greater than symbol, what we're going to do is make a little comment to ourselves that we're going to be drawing this line as a dashed line. So we'll come back to the purple when we're ready to graph that, and we'll draw it in using a dashed line. So again, what we would want to do is take that equation and solve it for y so that we get that slope-intercept form, y equals mx plus b, which means that we would have to subtract a 2x on both sides and divide by 3 on both sides. That means that as far as starting things out with our drawing, we would start by putting our y-intercept in there, and then we would use our slope to find other points. And we're going to be doing that in the purple, so let's go ahead and switch back over to the purple and put in that y-intercept, 0, 2. From there, our slope, bottom number is a 3, so we start by defaulting to move right 3. Because the top number would then be negative, that's going to be down 2. So move to the right 3, 1, 2, 3, move down 2. So starting from the purple point, right? 1, 2, 3, move down 2. So we've got a point there on our x-axis that we can use. If you chose, in fact, to go the other way, though, just to mention that idea, rather than interpreting the bottom number as moving to the right, you can interpret that as moving to the left, which would mean that the top number would mean that you move to the right, or excuse me, move up. Butterfingers. 1, 2, 3, left, 2 up. So we could do that as well. And that would give us plenty of points to be able to draw in that dashed line. We can go ahead and draw it in solid to start out with. And then we can use our eraser to go ahead and create the dashed appearance for that. Then, that takes care of drawing the line. We would want to move on to which half, either you could say left versus right, or the lower versus upper half of our drawing is going to actually be the rest of our solution to worry about. So we're going to pick a point from one of those regions, either the lower or left, or the upper or right. Well, since I just mentioned that the nicest, quickest thing for us is going to most often be to pick the origin, we can pick the origin this time. Let's go ahead and do that and test out how that works in our original inequality. So here's the origin marked in green. When we test that out in our inequality, 2 times 0 plus 3 times 0 is greater than 6, yes or no? Well, 2 times 0 is 0, 3 times 0 is 0, 0 plus 0 is 0. So 0 greater than 6, well, that is false. So that means that we would shade the region not containing our test point. Well, the region that does not contain our test point would be the right, or again we could say upper region. So we would want to shade in everything that is to the right or above our purple line. In this particular case, as I'm coloring things in this particular case, none of the points that are on the purple line will satisfy our inequality. None of those will work because of the type of inequality symbol that we have. So none of those points that are on our dashed purple line are going to be part of our solution. All the points that are shaded yellow will be. So if we had actually checked one of those points, then we would have come out with a true inequality statement. Well, since we went with the easier route, we picked 0, 0. That was false. These don't work. By process of elimination, these do. So that's the way that these go if we are working through individual inequality problems. You can see peeking up here at the bottom of the screen that we could now also take those individual problems and tie them together. So we have those previous 2 comments from a while back about union and intersection with inequality problems. Problems that are put together with the word and versus problems that are put together with the word or. And we had those cute little ideas that when we had and, we were looking at the overlap, and we used our little color idea here, yellow and blue make green, and so things that are put together with the word and would end up having a green overlap, a green solution. And anytime we had 2 of these or more, because we could legitimately have more, anytime we had 2 or more that were put together with the word or, then in the case of or, we're lumping everything together, which means we're shading everything orange. And once all of that stuff is drawn on a single grid, we can see what's yellow and blue makes green, or in the other kind of problem, everything that comes together and is shaded in orange. So we would be doing 2 separate problems on a single grid, either doing one problem yellow, the other problem blue, where yellow and blue make green. Or instead, for problems that are put together with the word or, we would do one problem in orange, then do the second problem in orange on the same grid, and everything that gets colored orange ends up being the solution.